going to be discussing similar figures with our objective being to identify the 3 critical attributes of similarity. Now, before we begin, if you do need a refresher on some of the vocabulary terms that we use in similar figures, I have included them here for you. So if you want, you can go ahead and pause the video to look over them and resume when you're ready. Moving into our first characteristic of similar figures. First of all, they have to be the same shape, similar to what I have included here for you with my 2 right triangles. Our second characteristic of similar figures is that our angles have to be corresponding, meaning the angles in matching corners have to be equal. So if you look here, you're going to notice how both angle A and angle A are 40, angle B and angle B are both 90, and then angle C and angle C are both 50, giving me my corresponding angles. Our third characteristic is that the corresponding sides have to be proportional, meaning what you do to one side, you do to the other. In this example, if you look here at the 4 feet going into the 16 feet, this is using a scale factor of 4. Now we look at our hypotenuse of 5 going to 20, also using a scale factor of 4. And then we look at the bottom of 3 feet going to 12 feet using a scale factor of 4, giving us our corresponding sides, which lets us know that our 2 triangles are similar because they follow the 3 characteristics of same shape, corresponding angles, and then corresponding sides. Now that we reviewed the 3 characteristics, let's go ahead and do some practice problems. For this first practice problem, it's asking if the 2 triangles are similar. You can go ahead and pause the video to look over the 2 triangles, decide what your answer is, and then resume when you're ready. If you answered no, you are correct. Because if you notice, the 2 shapes are triangles, but once we get into the corresponding angles, just looking at the first set of angles and angle A, they are not equal, letting us know that these 2 figures are not similar. For our second example, once again, we're working with 2 more triangles. You can go ahead and pause the video once again, look over the 2 to decide what your answer is, and then resume when you're ready. If you answered yes, you are correct. Because they are the same shape, they are both triangles. If we look at the corresponding angles, both X and X are 40, both Y and Y are 70, and both Z and Z are also 70, giving us our corresponding angles. And then lastly, our corresponding sides. To get from 6 to 18, we used a scale factor of 3. And then once again, 6 to 18 uses a scale factor of 3. And on the bottom, to get from 5 to 15, we also used a scale factor of 3, giving us the corresponding sides. For our third example, here you're working with 2 quadrilaterals. You can go ahead and pause the video again to identify whether or not you think the 2 quadrilaterals are similar, and then resume the video when you are ready. If you answered yes, you are correct. Because once again, we do have 2 figures that are the same shape. We have 2 parallelograms. For corresponding angles, the angles in matching corners. On the top left-hand side, we have 100 degrees for both. Opposite of that, on the bottom right-hand side, we also have 100 degrees for both. And then on the top right-hand side, we have 80 degrees and 80 degrees. And then on the bottom left-hand side, we have 80 and 80, giving us our corresponding angles. And then lastly, the corresponding sides. When looking at the 4 feet to 20 feet, we use a scale factor of 5. And for 7 to 35, we also used a scale factor of 5. So here, our 2 parallelograms are similar because they follow the 3 characteristics.